Welcome back, mathematicians. All right, so this time I want to talk about difference of squares. These things are factorable, by the way. You just have a zero for your b term, but instead of like maybe having an explanation of a whole long explanation, instead I just wanted to look at a few examples, right? So let's look at um, the word for literacy purposes, right? So a difference is a subtraction. And I have a difference of squares. So that means I have a subtraction of two squares. And if you look at this guy, it should come together that we have two squares. So the first one is pretty obviously a square, right? It has a little 2 right there. But is the second one a square? And what we should find it is a square. It's 3 squared. Okay? And these are easily factorable. So you could do the diamond method or the guess and check method or something like that to figure this out. Or you could not, right? If you know this one simple trick, right? If you could figure out what the square of this 9 is, then you get essentially two of the roots or the x-intercepts for free. It's just like that, okay? And that's it. That's the simple trick. If you can go from here to here, you could do that instantly. It's called the difference of squares, okay? So again, I just want to go through a few different examples of, let's see, let's do 16x, actually, let's make a different letter. Let's do y squared minus 36, okay? So this one is also a difference of squares, right? This guy is a square, this guy is a square. So in other words, you could break it down like this again, and as an exercise, I encourage you to do so, but if you can see that they're both squares, you can go directly. My first term is a 4y squared, so 4y minus 6 and 4y plus 6. And I get students asking me a lot, does it matter if the plus comes first and the minus comes first? And I always tell them, well, in multiplication, does it matter which number comes first? It doesn't, right? So 2 times 3 is the same thing as 3 times 2, right? So there you go. And then let's look at another one. Let's call it a z squared, oops, minus 3. All right. And here's the big question. Can I find a difference of squares here? Turns out I can, right? I just have to be a little bit clever. And in these instances, what I did is took a square root of that 36 and I put a 6 there, right? I took the square root of that 9 and put a 3 right there. In this case, what I want to do is take the square root again. So my first term is just z, and my second term, I need a z plus. My second term should be the square root of 3, which is, that's what I could do, square root of 3. So you don't see this too often. However, if you do see it, and you're looking for x-intercepts, there you go, right? Instead of using the quadratic formula, I can find it instantly. And that makes it very, very useful for us, okay? So what I wanted to do also is look at something that doesn't work, right? So I get a lot of students a lot of times telling me that z squared, oops, let's do x squared plus 49 is equal to, they tell me that this is equal to x minus 7, x plus 7. Um, they tell me that these two things are equal. I'm going to say that they're not. So as an exercise, show me that these two things are not equivalent, right? By working this side out. So use the distributive property and tell me what this actually equals, okay? And you should see a difference between these two, all right? Also, while we're at it, to kind of clear up some other misconceptions, show me this one as well, right? I get students telling me that this guy is equal to x plus 7 squared, or x plus 7 times x plus 7. So show me those two things in your notes before you come up to the ring of fire. All right, thanks, and I will see you next time.